Hello everyone and welcome to this Spacewalkers live session on which I will present an overview and reference design of Metro Ethernet networks and how Metro Ethernet services can be implemented in AOS. My name is Abu Bakr Dongola. I am a network solution architect working for the Network Business Division at ALE. Here's the agenda. I will start with presenting an overview of Metro Ethernet networks and the standardizing body called MEF Forum. I will go through a few standards, terminologies, and service types used by MEF Forum. Then I will discuss how we can implement the Metro Ethernet service types in AOS, such as E-Line, E-LAN, and E-Tree. I will then present a few Metro Ethernet features available in AOS. After that, I will go through the management methods of your network devices and different types of Metro networks, such as SPB or MPLS. Then I will speak about quality of service techniques which can be used and implemented in Metro Ethernet networks. I will then provide an overview of the operations, administration, and maintenance tools and features and how they can be utilized. Next, I will present the Metro Ethernet OmniSwitch portfolio. Then I will go through the network reference design and how best to position our Metro Ethernet portfolio. I will close with some key takeaways. So let's begin.
So what is Metro Ethernet? Metro Ethernet was first only used in metropolitan areas. That's why it's called Metro Ethernet. However, nowadays it's used for long distance WAN links and it's used to connect subscribers to a service provider network or as a transit service. It can also be used in smart city networks since it is a metropolitan network. It is sometimes used synonymously with carrier Ethernet, but they have a different meaning. Metro Ethernet is actually a subset of carrier Ethernet. So what are the benefits of Metro Ethernet? It provides flexible bandwidth, scalability, and elasticity, which enables service providers or operators to sell a certain amount of bandwidth to interested customers and can be implemented over many different types of Layer 1 transport technologies. So MEF Forum is the non-profit defining body to standardize and define carrier Ethernet services with attributes and parameters. It develops the technical specifications and certification requirements to promote agreements and interoperability of carrier Ethernet services. This will help promote providing seamless end-to-end connections at defined service level specifications. MEF Forum's work focuses on 4 key areas as shown on this slide, which is encompassed within what they call the MEF 3.0 Global Services Framework. MEF Forum represents standards for defining, delivering, and certifying assured digital services orchestrated across a global ecosystem of automated networks. The MEF 3.0 Global Services Framework components are services, lifecycle service orchestration or LSO APIs, certifications, and community. In this presentation, I will focus on services component of this framework. So let's first introduce a few key terminologies which are used by MEF Forum in their specifications as presented on this slide. The first one is the UNI, or the User Network Interface, shown in purple. It is the physical demarcation point between the responsibility of the subscriber and the customer edge, or CE, and the responsibility of the service provider, the provider edge, or PE. Of course, this will depend on whether the CE is managed by the service provider or the subscriber. Then we have the ENNI, or the External Network-to-Network Interface, which is shown in red in this slide. It is the reference point representing the boundary between the two operator carrier Ethernet networks and are operated as separate administrative domains. Then there's the EVC, which is the Ethernet Virtual Connection. It's an association of 2 or more UNIs that limits the exchange of service frames to UNIs in the EVC. Finally, an OVC, or an Operator Virtual Connection, is the association of UNIs and ENNIs within a single carrier Ethernet network, where at least one of these external interfaces is an ENNI. Each association of an OVC and an external interface is called an OVC endpoint. MEF Forum may refer to the customer edge device as CE device, but they are often called CPE, or customer premises equipment. I will refer to it as CPE in this presentation. So there are currently over more than 70 MEF Forum standards covering MEF 3.0 orchestrated SD-WAN, IP, carrier Ethernet, and optical transport services. The slide here shows the key carrier Ethernet services standards. So when configuring a network compliant with MEF-forum standards, the operator or service provider should be aware of the service parameters or attributes of the service endpoints and how these attributes can be controlled and configured. They should also be aware of the technologies and protocols used to provide the end-to-end Metro Ethernet service. So there's two different types of services defined by MEF-forum. There's subscriber services and operator services. These standards include definitions and service attributes. There's also special topics or more in-depth topics as shown in the bottom of the slide, such as service OAM, layer 2 control protocol, or class of service and bandwidth profiles, and service activation testing. So MEF-forum defines specifications which contain service types, service attributes, and parameters for carrier Ethernet networks. It also specifies methods to deliver quality of service by traffic engineering based on queuing, scheduling, policing, and shaping. The values of the service attributes define the capabilities of a subscriber Ethernet service. This is defined in the MEF-forum specification 10.4. For a particular subscriber Ethernet service, there's three types of service attributes. Those that apply to an EVC, those that apply to a UNI, and those that apply to an EVC per UNI. So the three main service attributes covered in this specifications are endpoint VLAN map, class of service map, service level specification, bandwidth profiles, and PCP or DEI preservation. So the first one is endpoint VLAN map. So this attribute, it maps the service frames to the EVC endpoints based on a list of VLANs or all VLANs or untagged VLANs. So basically, how do I know which VLAN goes to which service? The same VLAN tag may be preserved or translated at egress. The next attribute is the class of service map. So the class of service map service attribute defines how to understand which class of service the subscriber wants. The class of service map service attributes may be mapped based on the service frames, based on the layer 2 control protocol, or based on service OAM service frames. The service frames could be based on the VC endpoint, based on the PCP field and the Ethernet header, or based on the DSCP value on the IP header. So then we have the most key attribute, which is the service level specification. So MEF-forum defines service level specification as the technical specification or the performance objective of the service level offered by the service provider. This basically defines the level of service or performance of service that the subscriber is going to get. The service level specification includes quality of service related performance parameters such as frame delay or latency, frame delay variation or jitter, frame loss ratio, and availability. This can be measured using service OAM tools, which I will cover on later on. So the next attribute, which is defined by MEF-forum, is the bandwidth profile, which can be at ingress or egress of the carrier Ethernet network. It is a specification of traffic parameters which informs or enforces limits on bandwidth utilization according to the service level specification, which was agreed upon between the subscriber and the service provider as part of the SLA. This enforcement can be applied at the UNI, EVC, or per class of service ID per EVC. This is achieved with policing of traffic, which uses color marking to identify conformant frames. Traffic parameters include the CIR, which is the committed information rate, or CBS, which is the committed burst size, excess information rate, which is the EIR, and the excess burst size, which is the EBS. Note that the total rate, sometimes known as the PIR, or the peak information rate, is the sum of the CIR with the excess information rate. Finally, we have the last attribute, which is the PCP or DEI, which is the priority quote point or drop eligibility indicator preservation, which defines if the service preserves the PCP bits or the DEI bits. So using the previously defined attributes, we can then create services using service definitions. The service types which are defined on this specification, which is 6.3, are E-line, E-LAN, and E3. So E-line, it's defined by MEF-forum as the point-to-point EVC. So it's simply a point-to-point connection between two nodes. E-LAN, which is a multi-point to multi-point service that connects a member of the UNIs, which could be two or more, and providing full mesh connectivity for those sites. So it emulates a topology to the customer of a bridged Ethernet network connecting the different sites. They are used to create basically layer 2 VPN services. Then we have E3, which is a routed multi-point service, similar to hub and spoke service. The hub is called the root and the spokes are called the leaves. A leaf UNI can only communicate with the root UNI, whereas the root UNI can communicate with any other leaf UNI. The difference between E-tree and hub and spoke topologies is that you can have multiple roots. So then these service types, they can have port-based or VLAN-based variants. Port-based, which performs all-to-one bundling, has the following service types. There's Ethernet private line or EP line, and then there's the Ethernet private LAN or EP LAN, and then there's the Ethernet private tree or EP tree. And the other variant is the VLAN based, where the EVC is identified by the VLAN ID. So it has the following service types: Ethernet virtual private line or EVP line, Ethernet virtual private LAN or EVP LAN, or Ethernet virtual private tree or EVP tree. So MEFORM specification 26.2, it defines the operator Ethernet service attributes and introduces concepts such as operators and super operators, which allows a hierarchy of relationships between operators. And then there's the concept of ENNIs, which is the demarcation point between operator, OVC, and OVC endpoints, which we have discussed earlier. Some of the key attributes defined in the standard include OVC endpoint VLAN map, which controls which VLAN will map to which VLAN at the OVC endpoints for packets which are sent from one operator to another. And then you have the concept of OVC endpoint egress class of service map, which defines how to mark packets which are sent from one operator to another for different classes of service. Another one is the available MEG level, which is related to Ethernet OAM and how they interoperate between operators. There's also many other attributes which you can refer to the specification for more details. So the operator Ethernet service definitions, which are defined on specification 51.1, are essentially the same as subscriber definitions, but they have different terminology. So the three service types are OLAN, OLAN, and O-tree, which are basically like the same as E-line, ELAN, and E-tree, but they're operator service types. So then there's specific services which include access E-line, access ELAN, transit E-line, and transit ELAN. So access services connect one or more UNIs to one or more ENNIs, and transit services connect ENNIs together. So now how can we implement some of these Metro Ethernet service types in AOS? So let's find out. So the first one is to implement E-line service. In case you have a backbone, SPB backbone, you may configure an SPB pseudo wire service, which is a simple point-to-point virtual wire or transparent circuit between two SPB nodes that will bridge the traffic between them. There's usually no forwarding decision or MAC learning to be made, and the packets are simply bridged from one end to another unchanged. So this simplifies traffic flow and hardware utilization as well. So one of the methods to implement ELAN connectivity is to use VLAN stacking, which is also called Q tunneling. This enables service providers to provide their customers transparent LAN services. VLAN stacking provides a mechanism to tunnel multiple customer VLANs, called CVLANs, through a service provider network using one or more service provider VLANs, called SVLANs. So this is done using 802.1q double tagging or VLAN translation. This service is multi-point in nature to support multiple customer sites or networks distributed over the edges of a service provider network. The AOS implementation of VLAN stacking offers functionalities such as implementing ingress bandwidth sharing across UNI ports, or rate limiting the ingress bandwidth on a per UNI port per CVLAN or CVLAN per UNI port basis. And also, it offers the functionality of mapping the CVLAN P-bit or DSCP value, which is the inner tag, to the SVLAN P-bit, which is the outer tag. And it also offers the functionality of creating SAP profiles for saving and applying traffic engineering parameter values. So VLAN stacking provides a simple layer 2 VPN solution for small-sized Metro Ethernet networks. VLAN stacking can also be used in conjunction with ERP or Ethernet ring protection, which is used in networks providing rapid convergence times, typically less than 50 milliseconds, in the event of a link or node failure in a ring network. It does this by dynamically rerouting the traffic through the backup links, which helps to maintain network uptime and availability. It is designed for networks with physical layer ring or interconnected ring structures and provide a protected single path of communication between any two nodes in the network. So ERP is defined in the ITU-T G.8032 standard, and it's used to protect against network failures and minimize service disruptions. So the OmniSwitch implementation of SPB, it provides a multi-point to multi-point or ELAN connectivity solution that connects customer sites across an SPB network. There's many benefits to use SPB in a Metro Ethernet network. First, it transparently extends layer 2 connections over a layer 2 backbone network, and it maintains a loop-free topology and makes efficient use of available bandwidth. So there's no blocking of redundant links. It calculates the shortest path automatically, resulting in low latency and sub-second convergence. It can also process a large number of customer MAC addresses without burdening the backbone network, since the BCB nodes in the middle, they do not perform MAC learning. It also provides segmentation of customer traffic, and it's very simple to configure and maintain. So there's many benefits in implementing SPB in your Metro Ethernet network. So should you use SPB or VLAN stacking with ERP in your ELAN implementation? When 50 millisecond convergence is required, it's better to use VLAN stacking with ERP technology. Otherwise, SPB is better positioned. SPB can be positioned in the core, and you can use ERP rings as well on the aggregation and access layer for value access switches. So in case you're using an MPLS backbone network, the MPLS Layer 2 VPLS protocol provides transparent LAN services between customer sites. VPLS, or Virtual Private LAN Service, it's a Layer 2 technology that allows multi-point to multi-point connectivity. The provider network emulates a LAN by connecting all the customer remote sites at the edge of the provider network to a single bridged LAN. A full mesh of pseudo wires needs to be established to form a VPLS. The PE must be capable of MAC learning, bridging, and replication on a per VPLS basis. The MPLS core network interconnects the PEs. It doesn't really participate in the VPN functionality. The traffic is simply switched based on the MPLS labels. So there's two methods which can be implemented in AOS for signaling. The first one is to use VPLS with MPPGP. So this option enables the auto-discovery of PEs or tunnel endpoints in the same VPLS instance and allows for signaling of labels. The second option is to use VPLS with LDP, or Label Distribution Protocol, which uses targeted LDP between PE nodes for signaling. The E3 service provides routed multi-point connectivity between UNIs or SAPs of an SPB service. SAPs might be designated as root or leaf SAPs. In this slide, BEB1 has root SAP configuration and BEB2 to 4 have leaf SAP configuration. In the E3 service, root SAPs can communicate to any leaf SAP and vice versa, but a leaf SAP cannot communicate with another leaf SAP. For example, traffic between BEB1 and any other BEB and vice versa is allowed, but traffic from BEB2 is not allowed to BEB3. Also, traffic between different SAPs in the same BEB will not be allowed as shown in BEB3. So the next session I want to cover is the Metro Ethernet features, which are available in our Metro Ethernet OmniSwitch portfolio, and where you would implement them in your network. So I will present the following features, which is Layer 2 control protocol tunneling, dynamic proxy ARP or MAC force forwarding, and PPPoE intermediate agent. And the last feature is the IP multicast VLAN feature. I'll present the OAM features separately in another section. So the next feature is Layer 2 profiles, which determines how control frames ingressing on an access port are processed. So when a port is configured as an access port, a default profile, Layer 2 profile, called def access profile. It's applied to the port with the default values for processing control frames. So it's shown on the table on the top right. You can also create a new profile and change the processing, but not all control protocols are supported with the processing action. So the table at the bottom shows the supported combinations. So an example is shown in this slide, considering that we are using the default Layer 2 profile. The customer B site 1, CPE, is sending STP traffic, or spanning tree protocol traffic, which is by default tunneled through the operator network to site 2. Customer A, site 1 CPE, the green colored CPE, on the other hand, when sending .1x traffic, it is automatically dropped. But when attempting to transmit LACP PDUs to the PE, it is accepted and the peering is possible. So Layer 2 profiles are applicable no matter what service technology we are talking about, whether it's SPB, MPLS, CRP, VLAN stacking, or VXLAN. So the next feature I want to present is MAC force forwarding feature. Dynamic proxy ARP or MAC force forwarding, it's used to control unwanted broadcast traffic and host-to-host communication. So it implements an ARP proxy function that prohibits MAC address resolution between hosts located within the same subnet but at different customer premises. So the dynamic proxy ARP enabled switch will forward all the traffic from the layer 2 clients to the head-end router, which is the gateway. This head-end router then filters and forwards the traffic from the local network or back to other clients in the same VLAN IP subnet. So in order to accomplish this, the dynamic proxy ARP combines the functionality of other switch features to dynamically learn the router addresses and act as a proxy for that router. So dynamic proxy ARP, it uses the port mapping and the proxy ARP and the DHCP snooping features together to implement this functionality. So the port mapping is a feature that forwards the traffic from user ports only to network ports, preventing any communication between layer 2 clients in the same VLAN. Port mapping prevents direct communication between clients in the same VLAN, forcing all the traffic to be forwarded to the head-end router. Proxy ARP, which is the second feature which is used by the dynamic proxy ARP, it's a feature which allows all the ARP requests received on the port mapping user ports to be answered with the MAC address of the head-end router. So the dynamic proxy ARP enabled router dynamically learns the IP address and the MAC address of the head-end router and responds with the router's MAC address instead of flooding the ARP request. And the last feature which is used is the DHCP snooping, which snoops the DHCP packets between the servers and the clients. And the DHCP snooping is used to dynamically learn the IP address of the head-end router as well. So here's an example of MAC force forwarding shown on this slide. So clients connected to the user port of the port mapping session, and the head-end router is connected to the network port of the same port mapping session. So DHCP snooping is enabled. So the first step is when DHCP discover is sent, it uses the DHCP acknowledgement packet to learn the head-end router IP. The second step is when the ARP request and the ARP reply are snooped by the switch to learn the head-end router MAC address. Now the dynamic proxy ARP is used. Whenever an ARP request is received from the clients on the user ports, they are intercepted by the switch, and the switch replies with the head-end router MAC address. So all traffic is now forwarded to the head-end router to be filtered. Since this feature uses the VLAN domain and port mapping of physical ports, it can be used with the ERP VLAN stacking solution to provide security by preventing inter-host communication unless passing through the head-end router. So a use case for this will be in triple play networks for service providers to prevent inter-customer communication. It can also be used. It can also be implemented in a provider-managed CPE connected to an SPB-enabled service provider network. So the next feature I want to cover is PPPoE intermediate agent, which is a means by which discovery packets of PPPoE are tagged at the access switch by the service provider by using vendor-specific attributes to add line-specific information at the switch. So the purpose is to help service provider and the broadband network gateway to distinguish between different end hosts connected over the Ethernet to the access switch. So the Ethernet frames from different users are appropriately tagged by the intermediate agent to provide this distinction. So the AOS implementation of PPPoE intermediate agent enables the rate limiting or insertion of vendor-specific attributes or VSA tags into the PPPoE active discovery or PAD messages. The tag is allowed to contain information such as the base MAC address of the switch, the interface, the customer VLAN, the system name, and the user-defined string, depending on the configuration. So the user may be connected directly to the access node or using a network interface device at the customer premises. If a user is directly connected to the access node, as shown on this slide, the access loop can be identified by the interface number, such as the chassis, slot, or port, or if the user is not directly connected, or multiple users are connected to the access node through a single port, the access loop for a particular user can be identified as a combination of the interface using the chassis slot port and the customer VLAN as well. So since this feature uses the configuration of client and trusted physical ports, it can be used with the ERP VLAN stacking solution to provide access control, billing, and a type of service which can be configured on a per user rather than per site basis. It can also be implemented in a service provider CPE connected on an SPB-enabled service provider network. So the last feature I want to cover is the IP Multicast VLAN or IPM VLAN feature, which is an innovative feature for service provider delivering residential voice and video services. It also allows enterprises or service provider to create a separate dedicated multicast VLAN to distribute multicast traffic. It reduces duplicate multicast traffic on trunk links between the IP multicast VLAN enabled router and the core multicast router. So this feature also provides multicast traffic isolation from the IP multicast VLAN enabled switch to the CPE devices. So the multicast traffic only flows from the distribution VLAN to the customer VLAN. Customer generated multicast traffic flows only through the customer VLANs, so the multicast router can control the distribution of such traffic. The IP multicast VLAN feature works in both enterprise mode, which is the default, and the VLAN stacking mode. So we will now discuss different methods of managing network devices in a Metro Ethernet network, whether it's based on SPB or whether it's based on an MPLS backbone. So there's usually two design options to consider when a service provider provides a service to the customer. The first option is that the service provider manages and owns the CPE device, and the second option is that the provider only provides a link to the provider edge device, and the customer manages and owns their own CPE device. So let's go over the different options to manage your SPB nodes. So the first one is to use out-of-band management network, which is the most recommended option, where there is a separate management network connected to the EMP port of the SPB nodes. Out-of-band management applies to any network infrastructure. It's not specific to MPLS or SPB core. The second option is to use in-band management. In in-band management, the management IP interfaces can be created directly on the control B VLAN, so no loop package required. The third option, which is not shown here, is to use a dedicated management SPB service and VRF. Of course, the best option to use is the out-of-band network for management. So in case the service provider manages and owns the CPE device, a dedicated CE management VLAN and IP address are defined at the CE. This CE management VLAN is tagged on the interface between the CE and the BEB. The CE management VLAN is BEB significant, and it's the same for all CE devices connected to the same BEB. The next hop CE management IP address on the BEB resides on this VLAN and belongs in the management VRF. CE nodes do not route management traffic, and the same concept applies to whether you're using SPB or MPLS network. So the next session I want to cover is quality of service techniques, which can be implemented in a Metro Ethernet network. So this is an important aspect to consider, which will support providing and complying with the service level specification agreed between the service provider and the customer. So quality of service is often defined as a way to manage bandwidth. It allows the network administrator to gain more control over the network, depending on the type of traffic, which is essentially important when a network congestion occurs. Since the service provider will use the Metro Ethernet network to provide services to end customer, there must be service guarantees. Using quality of service, a network administrator can decide which traffic needs preferential treatment and which traffic can be adequately served with best effort. Quality of service is implemented on the switch through the use of user-defined policies, port-based QoS configuration, and integration with virtual output queuing to manage egress congestion. So there's multiple quality of service techniques supported on OmniSwitch, including techniques for congestion management and avoidance. For congestion management, avoidance, traffic policing techniques such as tricolor marking can be used at the UNI ports of the Metro Ethernet network. A tricolor marking policy consists of a policy action that specify packet rates and burst sizes. This is similar to the bandwidth profiles I explained earlier as part of the MEFFORM subscriber service attributes. The policy condition defines the type of traffic for tricolor marking to meter and then color the packets as green, yellow, or red based on the conformance with the rate limits defined in the policy action. So there's two types of tricolor marking. There's a single rate tricolor marking and two rate tricolor marking. The difference is that the two rate tricolor marking considers the peak information rate. You may also configure the maximum bandwidth on the ingress or egress ports of the Metro Ethernet network using port or policy bandwidth policing. This can be set to the customer's purchased bandwidth from the service provider. In case you're using VLAN stacking services, you can define the traffic engineering attributes that are applied to the customer traffic that is accepted on the UNI ports associated with the SAP profile. This includes ingress and egress bandwidth rate limiting. Note that by default, if there is a conflict between the VLAN stacking service attributes and the quality of service configuration, the VLAN stacking attributes are given precedence over quality of service policies. However, this default behavior can be modified. For congestion management, you can apply queue-set profiles to the UNI ports depending on the customer's type of traffic. The default queue-set profile, QSP1, is based on 8 strict priority queues, and there are different predetermined profiles in the OmniSwitch implementation depending on the platform. You can also create a custom profile by importing a predefined queue-set profile to use as a template for the custom profile. This is where you may define specific attributes such as CIR, PIR, queuing weights, and the queue scheduler. As you can see, there's many QoS techniques available, but it should be noted that QoS quality of service can be complex and difficult to manage. Simple quality of service techniques such as traffic shaping and policing are needed for Metro Ethernet network for rate limiting and efficient use of the resources, while other QoS tools are not required if bandwidth capacity is available. In an SPB network, traffic is classified at the SAP, and the classification does not change as the traffic traverses the backbone until it exits through another SAP at the destination BEB. Trusted SAPs copy the class of service markings from the incoming VLAN tag onto the B VLAN tag. If the incoming traffic is not tagged, then the port's default priority is used. Untrusted SAPs set the class of service markings to the user-defined value. No further classification based on inner layer 2 or to layer 4 conditions is possible within the SPB backbone due to the MAC and MAC encapsulation. When using an external or two-pass routing, the standard VLAN port must be set to trusted and use class of service and not DSCP to preserve class of service markings end-to-end. When using inline routing, no configuration is required since the access ports are automatically trusted and default classification is set to the priority value in the VLAN tag. Next, we will go through the OAM features which are supported in AOS. OAM, or Operation, Administration, and Maintenance, are tools and features that provide network fault detection and management, performance monitoring, and the resiliency required to guarantee end-to-end service delivery. I'll present a few tools and features available in AOS OmniSwitch Metro Ethernet portfolio, which includes Service OAM and Service Assurance Agent. So connectivity fault management divides the service network into different administrative domains, which might be called operator, provider, or customer domains. Every administrative domain is linked with one maintenance domain. Maintenance domains are assigned a unique level number between 0 and 7 to help identify and differentiate the maintenance domains within the domain hierarchy. For example, operators are assigned levels 0 to 2, service providers are assigned levels 3 and 4, and customers are assigned levels 5 to 7. The components of the connectivity fault management as per the standard includes the maintenance endpoint, or MEP, the maintenance intermediate point, or MIP, and the maintenance association, or MA. A maintenance endpoint, or MEP, is the boundary of a maintenance domain. It supports the detection of connectivity failures between any pair of MEPs in a maintenance domain and can initiate or respond to OAM frames. MEPs prevent leakage between domains. A maintenance intermediate point, or MIP, passively receives and responds to OAM frames. It supports the discovery of paths between MEPs in a maintenance association. A maintenance association, or MA, is a logical connection between two or more MEPs. It monitors the connectivity of a particular service instance or VLAN. Connectivity fault management is commonly used by the customer between the CPE devices or by the service provider between the PE devices. So connectivity fault management, or CFM, in an SPB network is most useful to perform layer 2 trace and layer 2 ping for analysis and troubleshooting. Other aspects of CFM, such as fault detection, which are important in provider backbone bridging, are less important in SPB because SPB has an ISIS control plane. These functions, CCM functions, are not currently supported in conjunction with the SPB. OAM is supported at the B VLAN level as shown on this slide. Virtual MEPs must be configured for all BVLANs and BEBs, and optionally also for BCBs. MIPs are automatically created and do not need to be explicitly configured. OAM is supported at the VLAN level or between layer 2 access switches connected to BEBs over SAP UNIs. This is useful in layer 2 deployment for testing end-to-end service connectivity between sites. OAM at the VLAN level must be set to a higher maintenance domain level than the BVLAN OAM. When using ERP VLAN stacking solution, MEPs on a per customer VLAN, CVLAN, and SVLAN allow supporting connectivity and fault management on a per CVLAN basis. MEPs can be configured on the UNI end of the provider bridge. The CVLAN-based MEP will assist the service provider to instantiate an MEP instance for the customer VLAN on the UNI port to perform OAM action for individual CVLAN traffic bound to an AVC. So CFM, as defined in the standard 802.1 AG, includes features which are used to help network administrator to detect, verify, and isolate when a problem occurs in the network. So the features include service availability and fault monitoring using CCM messages or connectivity check messages. So these are multicast messages exchanged periodically between MEPs to detect any loss of service connectivity between MEPs. These messages are also used by MEPs and MIPs to discover other MEPs within the domain. CFM also provides fault verification using loopback messages and loopback replies. So these messages are transmitted by an MEP to a specified MIP or MEP to determine whether or not the maintenance point is reachable. So the receiving maintenance point responds to loopback messages with a loopback reply. This mechanism is not used to discover a path to the destination. It's similar to the ping function. So another feature that CFM provides is fault isolation and path discovery using link trace messages and link trace reply. So these messages are transmitted by an MEP to trace the path to a destination maintenance endpoint. The receiving maintenance point responds to link trace messages with a link trace reply. This mechanism is similar to the UDP traceroute function. So OAM can be used to verify connectivity between BEBs and an SPB network by the use of loopback messages and loopback replies, and checking the route with link trace messages and link trace reply as well. So the OmniSwitch implementation of Service OAM is compliant with the ITUT recommendation, ITUT Y.1731 recommendation. It supports on-demand frame delay measurement, including frame delay, which is latency, and frame delay variation, which is jitter. This is an important performance objective since for those applications such as voice that cannot function with a high level of latency or jitter. So there's two types of delay measurements which are supported, one-way or two-way. It's of course recommended to enable NTP or network time protocol for clock synchronization to ensure accurate timestamps and measurements. The last feature I want to cover as part of OAM is Service Assurance Agent. So this feature, it enables customers to assure business critical applications as well as services that utilize data, voice, and video. So with Service Assurance Agent, users can verify service guarantees, increase network reliability by validating the network performance, and proactively identify network issues. Service Assurance Agent uses active monitoring to generate traffic in a continuous, reliable, and predictable manner, thus enabling the measurement of network performance and health. Service Assurance Agent is used to send periodic pings or loopback tests to peers over the network. This is done using standard IP ping packets, proprietary MAC pings, and Ethernet OAM tests. Each SAA test or Service Assurance Agent test can specify threshold times for jitter and round trip time. So when a SAA processes an iteration of a test session, it will compare the results against a certain criteria to see if an SNMP trap should be sent. Finally, for our last section, I will present a high-level overview of the OmniSwitch portfolio that can be positioned for Metro Ethernet networks and can support Metro Ethernet features. So the Metro Ethernet OmniSwitch portfolio overview is shown on this slide. For the 1G CPE copper, we can use the 6465T12 or the P12 models. For the 10G CPE models, we have the 6570M12 and the 12D models as well. For the 1G fiber aggregation, we have the 6570M U28 or U28D. For the 10G fiber aggregation, you can position the 6560 X10 model. For high-speed core, you can use the 6900 family, which supports up to 100G in a 1RU form factor. In terms of licenses, you will not be required to have an additional license for 6570M and the 6465T models, and they will have Metro features already inbuilt. However, for the 6560, a Metro Ethernet license is required. If required to have 10G, 4 times 10G uplinks on the 6570M U28 model, you will require a 10G license for it. So the AOS MPLS can be positioned for enterprise customers at the access, aggregation, or as an end-to-end network. It's a great cost-effective value proposition for enterprise customers in medium to large enterprises requiring an MPLS solution. So ALE has been certified by MEFFORM for its latest generation of Metro Ethernet switches. ALE OmniSwitch 6570M, 6560, and 6465T Ethernet switches were rigorously tested and validated as conforming to the meticulous specifications for performance, assurance, and agility of the MEF 3.0, so meeting the needs of service providers, operators, smart cities, and enterprises. MEF accreditation of ALE OmniSwitch models provides Metro Ethernet customers assurance that their user traffic can be safely carried across service provider networks in a flexible, resilient, and scalable manner. All the accredited switches are also optimized for OAM, and users can easily identify flow-based issues, view quality of service settings, analyze traffic patterns, and perform handover and on-demand testing and results monitoring.
So let us close with some key takeaways. ALE provides Metro Ethernet certified switches for enterprises and service providers, which support MEF-forum service types and advanced Metro Ethernet features such as OAM and QoS. SPB is a good replacement for MPLS in Metro Ethernet networks for a number of reasons. Number one, SPB is automated and simple to deploy. Number two, SPB supports virtual chassis, which increases resiliency. Number three, SPB will support hierarchical multi-level design and feature releases, so scalability will be improved. Another key takeaway is that EVPN is another consideration for Metro Ethernet customers. So make sure to check out our session on EVPN, which is available on Spacewalkers Live. Thank you.